Welcome back. This is Professor Needing once again. Math 068 this evening will deal with basic probability. So calculator will be a necessity tonight and a little bit of understanding about how probability works, and we'll see what we can accomplish for you. So in section 10, I'm going to make this a little bit larger there. We're going to talk about the basic probability and what happens inside of probability. And most people, when they talk about probability, talk about flipping a coin, rolling dice, things like that. And those are pretty good avenues in which to have the discussion. So really, when we talk about probability, we're talking about the likelihood that something is actually going to take place or something's going to happen. Okay, this type of thinking or this type of acclamation towards this is used often, and when we discuss how something might actually take place. I'm going to change over here, please. Give me a second to fill and sign, and I got to actually get it to where I can actually do a little bit of writing here for you. So whenever you're unsure about the outcome of an event, it says we can talk about the probability of certain outcomes and how likely they are. So if we're talking about something that has the possibility of a heads and a tail, then the probability of the coin landing on the heads is 50%. It's 1 out of 2. So it can only land here, or it can land here. And we're not certain about either one, but we know that each one has a probability or a plausibility of 50%. So the way we define an actual probability itself is the number of ways it can happen and the total number of outcomes. And by the ways it can happen, what that means is the ways what you want to happen can happen. So in this particular case, we'd write P, which is proportion or probability, but the proportion of getting heads is 1 out of 2, which is 50%. General facts about probability, kind of important right here. The general facts of probability are they can be expressed as a proportion that ranges from 0 to 1, 0.25, 0.27, 0.99, but it can't be 1.4, and it can't be negative point anything. They can also be expressed as a percentage from 0 to 100. A probability of 0 indicates there is no chance that this particular event will occur. I will predict that I am going to wear a yellow shirt on the 9th Sunday of the month. It can't happen because there's no 9th Sunday of any month. Probability of 1 indicates that an event is certain to occur. It is certain that after I'm done teaching chapter 10, I'm going to have to do chapter 11. Otherwise, they're going to get somebody else to do it for me. So it's certain to happen. The probability of an event A is often written P of A. That's how we say that. P of A. P of A indicates the probability of A taking place, and it's enunciated P of A. So when we talk about if P of A is less than P of B, then event A has a higher chance of occurring than event B. It has a greater probability. If P of A equals P of B, then the probability of the two events are equally likely to occur. And that was true in the above, the probability of flipping a head, the probability of flipping a tail. Those two things were exactly equal to each other. So in student exercise number 1, it says the concept of probability can be illustrated in the context of studying obesity in young children 5 to 10 who seek medical care at a particular pediatric practice. It says the population includes all children who were seen in the practice in the past 12 months and summarized below. So I'm going to scroll down so we can see just a little bit more. Now we can see the data. What is the probability of selecting a boy? Well, first of all, we have to see how many boys there are. And there are 2,560 boys over here. I'm going to change so I have a little bit of more leadway maybe on what I'm doing. Right here, 2,560 boys here. And of those 2,560 boys, there are a total of 5,290 total. So therefore, 2,560 divided by 5,290 gives me 0.48 as a probability. What is the probability of selecting a 7-year-old? Okay, well, the 7-year-old now is slightly different. The 7-year-old, I go to the 7-year-old column. I go find it here. And I have 913, again, out of the same 5290. So to take 713 and divide it by 5,290, I get 17% or 0.17. What is the probability of selecting a boy who is 10 years of age? Okay, well now I have to first of all go to the 10-year-old column. I have to find the boys who are 418, and I have to take those 418 out of 5,290, and I will get my probability of about 8%. What is the probability of selecting a boy or girl, so I have multiples here, who is at least 8 years of age? Well, if I go to boys and girls, I use the totals. They have to be at least 8 years of age. They have to be 8, 9, or 10. So if I take 8-year-old, 9-year-old, and 10-year-old and combine them for 2,645 items that are what I want, and I divide them by the total number, 5,290, I have a 50% chance. The same type of thing can be done here with eye color. When we talk about eye color, it says each student in a random sample of a senior local high school participated in a survey, and these students were asked and indicated their gender and their eye color, and the following table summarizes those results. So we'll jump back and forth after we find out what we need. Suppose that one of the seniors is randomly selected. What is the probability that the selected student is male? Well, I go back to the seniors, and I go back to the males. Males, 110. There are 110 of them out of 200, and 110 out of 200 is 0.55 or 55%. Suppose one of the seniors is randomly selected. What is the probability that the selected student had blue eyes? Well, if I go just to the blue eye color, they're 80, and 80 out of, again, these are all seniors, 200. 80 out of 200 is 40%. Suppose that one of the seniors is randomly selected. It has to keep telling us that because a random selection is the only way I can get a probability. What is the probability that the selected student is a male and has blue eyes? All right. If I find the males here and I intersect them with the blue eyes here, I am right here at 40. 40 out of that 200 is now 20%. So the word and indicates that I have to meet both pieces of criteria here. I have to be a male and I have to be, oops, I'm going to get rid of that. I have to be a male and I have to be blue-eyed. Both of those have to be true. Oops, sorry, I just added my signature. I didn't want to do that. I just simply wanted to do some redactyl drawing. Which one didn't I do? D. Suppose that one of these seniors is randomly selected. What is the probability that the selected student is male or has blue eyes? So you can be a male or you can have blue eyes. So if I go to the male, 110. If I go to the or blue eyes, 80. 80 and 110 is 190. Oops, right here. Oops, I'm sorry. It was blue eyes. I went with the wrong one. Blue eyes right here. It had to be male and or a blue eye right here. So this one or this one. And of that, there's 150, and 150 out of 200 is here. Suppose that one of the senior random selected, what is the probability that the selected student has blue eyes, given that the student is male? So now this one's different. Now in here, you have to be a male. So nobody, not the 200 group is no longer part of my group because I don't want the females in the group. I only want to know of the males, how many of them have blue eyes? Well, it's still the 40 because 40 of them had blue eyes, but now it's out of the 110 group because 110 was the total number of males. So notice how the percentile changes from 75% to 36%. And for the last one, suppose that one of the seniors is randomly selected. What is the probability the selected student is male given that the student has blue eyes? So we have to meet the first condition that you have blue eyes, and then we have to see about you being male. So now, first of all, we meet the first condition that you have blue eyes. The people who have blue eyes are 80, and the number who are male are 40, and we have 40 out of 80. Notice how these three change completely. I'm going to put a notation by these. These three sound very super similar to each other, but yet at the same time, they are completely different from each other. Please complete student exercise number 3 and include that as part of your upload for your completed upload for Chapter 10. In Chapter 11, we'll be continuing on the discussion with the interpretation of inequalities.